Hi, my name is Daniel. Welcome to this journey through smart electrical systems and automation. Today we are going to study the chapter, which is Sensors and Actuators for Smart Systems. In this chapter, we'll explore how sensors detect changes in the environment, how controllers process that information, how actuators respond with physical actions, and how proper wiring and panel design ensure everything works safely and efficiently. Let's dive in. Control System Components Overview. In any smart electrical system, there are four main building blocks: sensors, controllers, interfaces, and actuators. Sensors capture real-world parameters like motion, light, or distance and convert them into electrical signals. Controllers, such as microcontrollers, MCUs, or programmable logic controllers, PLCs, process this sensor data and make decisions. Interfaces, like relays or motor drivers, act as the link between controllers and actuators by conditioning signals or boosting power. Finally, actuators like motors, solenoids, and buzzers perform the actual physical action. All these components must be properly wired and integrated to form a safe, reliable control circuit. Presence detection. PIR sensors, passive infrared, PIR sensors, detect motion by sensing changes in infrared radiation in their field of view. They do not emit energy themselves, which makes them energy efficient. Typically, they have a detection range of 5 to 12 meters with about 110 degrees coverage. When motion is detected, they output a digital high signal that can trigger actions like turning on lights or activating alarms. A common module, the HCSR501, has adjustable sensitivity and delay time, making it versatile for security systems and automated controls. Light sensing, LDR modules. Light-dependent resistors, LDRs, change their resistance based on light intensity. Resistance decreases as light increases. The response time is in the tens to hundreds of milliseconds, and they are most sensitive to green-yellow light, around 550 nanometers. Most LDR modules include a comparator circuit like LM393 to produce both analog and digital outputs with an adjustable light threshold. This allows for applications such as automatic street lighting or brightness-controlled displays. The module's sensitivity can be fine-tuned using a potentiometer. Distance measurement. Ultrasonic sensors. Ultrasonic sensors, such as the HCSR04, measure distance by sending out a burst of sound at 40 kHz and timing how long it takes for the echo to return. The basic formula is distance equals speed of sound times time divided by 2. They can measure from 2 centimeters up to 4 meters, with a resolution of about 0.3 centimeters. These sensors require 4 connections: VCC, GND, trig, and echo, and a short trigger pulse of 10 microseconds to operate. Applications include robotic navigation, parking assistance systems, and liquid level monitoring. Power control, relay modules. Relays are electromechanical switches that let a low power control signal switch a higher power load, providing electrical isolation. A common relay module may include an optocoupler for isolation, a transistor driver to energize the coil, and a flyback diode to protect against voltage spikes. Contacts are rated for AC or DC loads, often around 10 AmpEres. Multi-channel relay boards allow control of multiple devices at once. They are essential for safely switching mains voltage in automation projects. Fluid control, solenoid valves. Solenoid valves control the flow of liquids or gases using an electromagnet to move a plunger. They come in normally closed, NC, or normally open, NO types, depending on whether the valve is open when unpowered. They can operate on various voltages, 12 volts, 24 volts DC or AC versions, and have specific pressure ratings. Because they are inductive loads, Driver circuits must include flyback diodes for DC or MOVs for AC to protect electronics. These are widely used in irrigation systems, washing machines, and industrial fluid control. Motor control, driver modules, H-bridge driver circuits, like L298N, allow bidirectional control of DC motors and can handle voltages from 5 to 35 volts. Stepper motor drivers, such as A4988, provide precise movement by energizing coils in a sequence and often support microstepping for fine control. Motor drivers typically include safety features like overcurrent protection and thermal shutdown. PWM, pulse width modulation, is often used for speed control. These modules are key in robotics, conveyors, and automated machinery. Output indicators, buzzers and LEDs. Piezo buzzers generate sound when an AC voltage makes a ceramic disc vibrate, and they are used for alarms or notifications. LEDs are low-power light sources that need current-limiting resistors to prevent damage. Both serve as feedback devices in control systems. Buzzers give audible alerts, while LEDs give visual signals. High-brightness LEDs may require transistor drivers for proper operation. Together, they make systems more user-friendly by communicating status or warnings. Sensor-actuator interfacing, best practices. When connecting sensors and actuators, signal conditioning, like filtering and amplification, ensures accuracy. Power systems should have separate digital and analog grounds to reduce noise, and decoupling capacitors should be placed near ICs. Protection circuits like transient voltage suppressors, opto-isolators, and fuses safeguard components from electrical faults. Always verify wiring before powering up a circuit. Good documentation with proper schematics helps in troubleshooting and scaling systems.